Cybersecurity for vehicles is really important. Today, a vulnerability in the software in your vehicle could result in it being stolen by organised crime or thieves. But if we fast forward 10 years into the future and think about autonomous vehicles or semi-autonomous vehicles, a fleet of those driving around, a hack on that would be more like a critical national infrastructure issue if you could incapacitate a whole city or a whole country.
There's quite a great opportunity with autonomous vehicles in the future to improve productivity, to reduce the number of road accidents. And these systems rely on a fusion of different sensors and connectivity solutions. And if you're going to be making split-second autonomous decisions, you need to have great resilience to cyber threats.
So the AutoCHERI project is looking at applying a new chip-level innovation to the automotive industry. This chip innovation is called CHERI, which stands for Capability Hardware Enhanced RISC Instructions. And it's a new instruction set for processors, which is more secure and increases the memory safety.
The AutoCHERI project is an Innovate UK grant-funded project under the Digital Security by Design programme. The first chip to use the CHERI instruction set is called a Morello. It's a chip from ARM. And in this project, what we're doing is we're taking the Morello and we're putting it into one of Beam Connectivity's telematics control units. And then what we're doing with our consortium partners is we're investigating what is the impact, what is the benefit of using Morello for the cyber resilience and therefore the safety of vehicles.
So there are 5 partners in this project. Beam Connectivity, we're leading the project. We've got the University of Exeter, who are providing cybersecurity and code level support. We've got the University of Swansea doing pen testing and providing threat analysis. Applus IDIADA, who are doing a lot of systems engineering and looking at the requirements and the system architecture. And finally, the Compound Semiconductor Applications Catapult, who are our kind of interface into the industry.
It's a very healthy interface with policy units and with international bodies that are all looking at hardware security, looking at how we build over a secure and resilient semiconductor future.
CSA Catapult has a legacy of many years working with industry, so that means we have very close ties across the supply chain, and in particular automotive is an area which we have a great strength, and within multiple projects we have a reach into many of the players who would be working on this type of technology.
We're using our access to the supply chain, different stakeholders, for our business development and commercial functions. We're setting up stakeholder meetings, engagement, and an industry advisory group.
The University of Exeter, our research group, is focusing on developing secure and trustworthy software systems. So within the AutoCHERI project, we are evaluating how that novel hardware architecture can help to develop more secure software.
Applus IDIADA provides services to the automotive industry through development engineering, vehicle testing and homologation. We provided the vehicle, installed the equipment and ensured all of that equipment worked at the vehicle level. We were also responsibility for the cybersecurity analysis phase.
Connected and autonomous vehicles expose a great number of wireless radios. So you've got Bluetooth and Wi-Fi to a smartphone or a home Wi-Fi hotspot. You've got satellite communications for GPS, but also for non-terrestrial networks, so Starlink and communication satellites. You've also got cellular connections to OEM back offices. All of these connections together become different attack vectors into the system. And so a connected and autonomous vehicle inherently has more of these, which makes it more susceptible to attack. When people write software, there are quite often vulnerabilities in there which are not found until much later once it's in the field. They estimate that 60 to 70% of all vulnerabilities in software are caused by memory safety. So that's where a developer has allocated a set of memory and overwritten that or gone too far. Now these aren't often picked up during development time, they manifest in the field. And sometimes they're never found, sometimes they're found by malicious hackers.
We've seen a number of threats recently that are targeting the hardware of modern systems. The UK has embarked on a major project under the Digital Security by Design initiative to address low-level threats at hardware level and for us to design them out.
The unique feature of this project is that CHERI checks for those memory violations in hardware instead of in software, and that promises to be much more efficient and much faster than if you do the same checks in software. And also, of course, for an attacker, it's much harder to override hardware checks than it would be to override software checks.
Within the next 10 years, we're going to see automotive networks consolidate from being hundreds of small computers connected via a network in the car to consolidated high-performance compute nodes in the vehicle. So you might have a handful of those. When that happens, we'll have lots of separate software functions all running on the same hardware. Now, if you don't have memory safety, that means that one software feature can interfere with another. It's like on your mobile phone, one app interfering with another app on your phone. So what we're trying to do is ensure that memory safety is in place and compartmentalization is in place so that each individual software function can't interfere with others.
At Swansea University, our focus is mainly on 4 use cases. In the first use case, then it's looking into the cybersecurity aspect of over-the-air update. Then it's also looking into the diagnostic data that's sending from the vehicle to the cloud service. The next one is that it look on the communications between the vehicle and the cloud for traffic and accident advisories. And finally, the last one is that it's looking at the remote control of the vehicle.
For each of the use cases, we're looking at the impact of CHERI, of Morello, on cyber resilience and on safety of connected vehicle applications. After 19 months, we've implemented all 4 use cases. We've done that first of all in a laboratory environment, and then we've taken it to various testing grounds, for example, in Millbrook, where we've rolled out the use cases and then we've tested that they're working. We're now doing penetration testing to check whether from an independent perspective, this has also improved the cyber resilience of the systems.
With the reporting and the findings that we've demonstrated so far, and with the input significantly from the industry advisory, we're now at a position where we could develop bigger, larger scale projects. We can take it out into other critical parts of the vehicle. We can share that information and work in partnership with industry. Another key element following that would be to start to work within standardisation and within the different regulatory rules that are required there to meet compliance.
We've got very good engineering teams at Beam Connectivity, at Applus IDIADA, at our partners at University of Swansea and University of Exeter. So the technical development has gone really, really well. And in fact, we're mostly wrapped that up. What we're trying to do now is write a number of reports which outline the benefits of CHERI and Morello.
The next steps from our perspective is the knowledge we've gained gives us a good understanding of current and future technologies, and that will help us work with our automotive clients to ensure that they are benefiting from the knowledge that we've now gained. CHERI is an understood technique to reduce some cybersecurity threats used in other industries and other applications. This project has demonstrated how it can be used within an automotive application and thereby demonstrates how the automotive clients and customers can benefit from the expertise from other technical areas.
At the moment, we are talking about a prototype architecture, prototype hardware that is not available to the general public, that is available within a research community. The next big step essentially is that it is widely available.
Swansea University's role in the AutoCHERI and DSBD initiative is twofold. The first area is to look at the risk assessments in terms of the CHERI and Morello integration in automotive systems. The second area of interest for us is, of course, the economic case of CHERI and how do we make sure that the early adopters integrate CHERI and Morello into their design cycle, into their products, and still have a commercially viable offering. The UK's recently announced National Semiconductor Strategy is pushing for hardware security as a key competitive advantage for the UK. The AutoCHERI project is critical in demonstrating to the automotive industry that adoption of CHERI is entirely feasible and viable, and there's very strong return on investment to be had.
One of the really exciting opportunities here is that anything that connects, that could be an IoT device, anything where we've got some form of control and we've got some form of connectivity, this technology can be applied. So we're really excited to think that this could cover a range of end sectors, could aerospace, rail. And so the opportunities for the application of the technology are enormous and very exciting.